In this lesson, we're going to be learning about squares and square roots. Our first goal of the lesson is that we will be able to solve problems involving squares and square roots. So let's first review quickly what a square is. So for example, if I have the number 5 and I want to square it, that means raise it to the second power. What this means is that I have 5 multiplied by itself twice. 5 times 5. And if I multiply that out, 5 times 5 is 25. So 5 squared would equal 25. And then we can do this process without this middle section once we know what we're doing. So for example, 7 squared, I can say is going to be 49. I know that because 7 squared really means 7 times 7, which is 49. And then we can work backwards in. So square root is working backwards from this. So if I know where 49 came from, then I take the square root of 49. That means what two numbers did I multiply by itself to get 49? And I multiplied 7 by itself to get 49. So the square root of 49 is 7. Another example, if I have the square root of 16, this is going to equal 4. And that is because 4 times itself is how we get 16. So the square root of 16 is 4. And then before we continue with some other examples, it's really helpful if we have a list of all the perfect squares. Examples like square root of 49 and square root of 16 where I know an exact number answer. For example, the square root of 1 is 1 because 1 times 1 is 1. The easier way to make this list is if we start with the answer, start with 2. Well, if I know if I multiply 2 by itself, 2 times 2 is 4. So the square root of 4 must be 2. 3 times 3 is 9, so square root of 9 must be 3. We already did 4. That's the square root of 16. We already did 5. Square root of 25 would be 5. And I can continue down this list. 6 is the answer to square root of 36 because 6 times 6 is 36. And I'm just going to continue down the list, squaring each number, and then finding the square root backwards. And we typically want to know the numbers 1 through 12 are the most common that we will find. So these are all perfect squares. They have a whole number answer. At the end of this lesson, we're going to look at some non-perfect squares and what we can do with those. But let's look at some more examples of what we can do with these perfect squares. So with this example here, the square root of a fraction, I can actually rewrite this in a different way that will sometimes help me. It is the same thing as the square root of x over the square root of y. And this can be helpful if we look at an example like this. So let's say we have the square root of the fraction 25 over 9. This looks confusing, but if we separate it like we did at the beginning here, this is the same thing as the square root of 25 over the square root of 9. And we know from our list off to the left over here that the square root of 25 is 5 and the square root of 9 is 3. That tells me that the square root of 25 over 9 is really just 5/3. And this works similarly with multiplication. The square root of x times y is the same thing as the square root of x times the square root of y. And we can also use this to solve some problems as well. Now let's look at our second goal, is that we can approximate the value of non-perfect squares. So let's look down here at the square root of 8, for example. 8's not in our list. So the square root of 8 is not going to be a perfect number, but we can still figure out what it's close to. So we would find, if I would have put square root of 8 in my list, well, 8 falls between 4 and 9. So square root of 8 would fall right in here, which means this is also between the values of 2 and 3. So then the square root of 8 must be between 2 and 3. So we might not know exactly what it is, but it's going to be somewhere between 2 and 3. So maybe 2.5 or 2.6. And because the 8 is closer to the 9 than the 4, I'd say it's probably closer to the 3. So maybe 2.8, 2.9. And we could look at another one. Let's say we want to look at the square root of 27. So I can do the same. And where would 27 fall on my list? 27 is between 25 and 36. That means the answer would be between 5 and 6. So that would be between 5 and 6. And if we look, the 27 is closer to 25 than it is to 36. So the answer is probably going to be closer to 5, maybe 5.2. So then we can estimate where these things might be at on a number line. So we said the square root of 8 was going to be between 2 and 3. So between 2 and 3 is the square root of 8. And we said the square root of 27 is between 5 and 6. So on the number line between 5 and 6, we said closer to the 5 is going to be the square root of 27. So we can estimate by first finding where the square root falls on our list, find the number it's between.